3 years ago, I made a video talking about window and glass, and in that video, I promised I'll go further into the actual selection of glass. Follow up, we may be late, but never absent. Today, we are in Geelong Glass to talk about glazing with my teacher taught me all about glass, Professor Mark Luther.
Glass is a material that has the properties very close to that of concrete. Think about it. Silica, sand, that's what glass is made out of, mainly. So the properties of glass are almost identical to the properties of concrete in terms of density, in terms of thermal coefficient, a heat capacity, and especially thermal conductivity.
When we choose glass, what are the items that we should look at when I'm evaluating what type of glass or window I should pick? What criteria should I consider?
What we often look at is what's called the U value. Now, we all are familiar with the U value as the inverse of the R value, the resistivity in conductance. And the U value is typically the reciprocal of the R value. The U value, so a smaller U value is actually a larger R value, right? So that gives us more resistance or insulation value in the glazing system. So we look at the U value. That's one thing, but we're very familiar with the U value from other materials that are opaque and not transparent. What we tend to further evaluate in glass because of its properties of being transparent or translucent are what's called the solar heat gain coefficient. And we'll talk about that a little bit more later. We further look at other systems when we're talking about the solar spectrum. And the solar spectrum allows as many different frequencies or wavelengths. Yep. And what's important to realize is that there's a portion of the solar spectrum that gives us what we know as visible light. And it's important in many glazing systems to look at what the visible light transmittance of a glazing system might be versus the solar heat gain that is being transmitted or admitted through the system. I'd like to talk a little bit about what we call double IG or triple IG units. Insulated glass units is what IG stands for. Here we have a double insulated glass unit. It has a cavity in between the glass, and the cavity is what gives it some better thermal performance in terms of its conductivity or its insulation value. The 4 mil Low-E plus glass is what I'm holding here. The biggest breakthrough in history was the idea of sealing and developing a double and triple insulated glass unit. The glass itself, the properties don't change, but the composition of putting it together with various thicknesses of air gap and filling those cavities later with different gas types such as argon or krypton make the performance of a glazing system superior to what it was 50, 60 years ago. I'd like to now focus in on the modes of heat transfer through glass. What is very important to realize is that there are three basic modes of heat transfer when a glass is exposed to solar radiation. We have, of course, the simplest and easiest principle, which is the solar ray being transmitted through the glass. The properties of the glass that allow a certain percentage of the incident solar to be transmitted through the glass. So that's pretty clear and understood. So we have the transmittance percentage of a glazing system or a single pane of glass. The next aspect related to that solar incidence is what gets absorbed in the glass itself. So the solar beam hits the glass and a certain percentage of absorption in that pane of glass takes place, heating the glass to a higher temperature. As it transmits to the second layer, again, more absorption takes place in the glass, heating the glass. And then we have what we call the transmittance. But going back to looking at the absorption aspect of the solar incident beam, heating the glass is important in the performance of the glass because we want to often transmit as little heat as possible in an insulated glass unit. In the summertime, we want to be protected from that solar beam. So the transmitted solar radiation and the absorbed fraction that enters the space is what we call the solar heat gain coefficient. Those two components, the transmitted and the admitted absorbed solar radiation going into the space that we're conditioning, are of concern. Those two factors make up the solar heat gain coefficient. Now, after the solar heat gain coefficient, we have what we call the U value performance of the glass. The U value is like with any other opaque material, the conductance or conductivity of the glazing system or the material system. And that relates to the thermal conductivity of the material of glass, in this case, itself, and the insulating aspect of the cavity. So we have an outdoor and an indoor temperature, what we call a delta T. If it's 30 degrees outside and 20 degrees inside, we have a temperature difference of 10 degrees. The U value is multiplied by that temperature difference, and we also include the area, but if we're just talking about 1 meter squared, then what we have is the conductance of that glass. Okay? So that's the heat that is admitted through thermal conductance alone. So the three components, the solar transmittance, the absorbed solar radiation that is admitted into the space, and the U value, all make up the performance of a glazing system.
When we talk about high performance glass or windows, the first thing come up in mind is about double glazing, and it's all about how we stop the heat loss at winter night. What can influence the property, Mark?
A single 4 millimeter clear glass has a U value of pretty close to about 6 watts per meter squared per degree Kelvin. So if you have a temperature difference of 1 degree between the outside and the inside, let's say it's 21 degrees outside and it's 20 degrees inside, that means heat's traveling always from hot to cold. So a U value of 6 means that 6 watts of heat are coming into the space per meter squared. Now imagine we're on a 35-degree day. We might be talking about 10 to 15 temperature difference, and we're going to multiply that by 6. So we're now into the hundreds of watts that are coming through based on the conductance alone.
Some of the advertisements claim a low E coating can help control solar gain. Is it true?
A low E coating may have some mirror characteristics, very little. Mainly, a low E coating has nothing to do with the overall solar transmittance of the glass itself. What the low E does, it performs a property of low emittance. What does low emittance mean? I like to use this analogy. If a boyfriend and girlfriend are very fond of each other, and they get together and they accept each other. They're two different panes of glass, and they relate very well with each other. So all the energy is transmitted between them. Now all of a sudden the girlfriend, she gets a low E coating, and she's reflecting the boyfriend from her, right? And the boyfriend's no longer acceptable. So that's what we should think of a low E coating. A low E coating is rejecting the solar spectrum, the heat portion.
The infrared, the long infrared.
The long wave, and possibly the infrared and the long wave spectrum. We have to look at those properties of the glazing system. But it's after the heat has passed through and it's heated up a surface. And that surface wants to emit or radiate to that glass, which has a low E coating. And the glass is saying, no, I'm not going to accept your heat. That's in the typically in the far infrared spectrum.
One thing when I use the infrared camera, I notice clear glass is a kind of heat mirror for the infrared. Why do we still need to add another coating for low E? And what are the different types of low E available in the current condition?
Look, there are very many, or two different really distinctive types, I guess, of low E. Not many, but two different distinctive types. One is a soft coat, a vapor deposition coat. That soft coat needs to be protected. And often a soft coat will be on one of the inside layers of a double insulated glass.
The cavity facing.
Yes, the cavity facing sides, right? With a soft coat, that's the case. I believe people like Pilkington and LOF, Libby Owens Ford, they made a very tough coat, low E film or deposition onto the glass, coating. And that coating was quite durable, and that could be exposed on the inside surface as well of the glass. The coatings, yes, they can vary. Some might only have an emittance value or an emissivity value, let's say, an emissivity value of 0.10, so 10%, 0.1, so 10%. Others that are very high performance can go down to, say, 2%. And so that's a huge difference when you can say that 98% of the infrared heat that's coming to that glass is being reflected back. That's a huge...
Sometimes they say huge.
...difference in radiation.
Well, that means for a 30% low E is the girlfriend that is slightly angry but still listen to you. And the 98% low E is she don't even answer your call.
Yeah, that's right. That's probably what we're talking about.
If we are only focusing on the energy performance of a window, we may need only a very small window that allows sufficient light come in and the heat that we need for winter to passively warm up the home. However, unfortunately, we have other needs coming from the window, such as our visual connection, the aesthetic. So when these two criteria are in conflict, how can we use the different property of the glass to balance the need between a energy efficiency and the visual and aesthetic for a big window?
We talked about the clear glass and we talked about the tinted glass. The tinted glass, Joseph, you referred to as us wearing our sunglasses.
Yes.
If we have a small window to wall ratio, we call it.
Yep.
So a small window aperture.
Such as a tiny window?
Little, tiny, small windows.
Well, we might say a window to wall ratio, we call it. Let's say 30% or less of our window, or our wall is a window, is glass. We would want the glass to be more on the clear side, allowing the transmittance in as much as possible of visible light to come through. So a high visible transmittance. As we move up in our window to wall ratio, where more window takes over, such as 60, maybe even 75 to 80%, we tend to want to go with a performance glass in terms of tinting and letting less heat and less of the visible spectrum through. Meaning that we have a huge aperture allowing sunlight to come through. We want to put our sunglasses on.
Yeah.
We might not even notice that the glass is the one I'm holding up, is as dark as it is. Once again, we said we're filming this indoors. If we were outside looking through this glass, it would be a totally different experience.
Our brain is an amazing machine. You don't even know how much compensation it will do. It's just like the same after we put on our sunny. The first 5 seconds or so, we may feel dark, but very soon, our brain and our eye would adjust to make it look as normal, as nice as a piece of clear glass.
One of the things that we talk about in a glazing system that gets very big is glare. And that's why we wear sunglasses, right? So glare is cut back through this tinted glass.
Since we are in the topic of tinted glass, when we look at window tinting for existing window, I got really confused because I see color tint, reflective tint, mirror tint, and low E, they call it tinting as well. So are they the same? What are the differences between these few types of tinting?
Well, Joseph, as you know, years ago we were confronted with this problem. And we realized that many different tints of glass are out there on the market by very prominent manufacturers flogging their new glass and types. Maybe they're boasting a tinted glass that allows a huge portion of the visible spectrum through that tint, but blocks the other part of the solar spectrum that's unwanted. These are often called tinted glasses, become heat-absorbing glasses. So if they don't have a very high reflective property on the glass and they're just tinted, then they are absorbing a huge amount of the solar energy that's incident upon them. Now, there's a bigger issue when it comes to tinted glass, and we are recently talking about this in terms of color temperature. And color temperature is very important when we're looking at the visible spectrum. If we start using a tint that is not allowing the colors of the visible spectrum to come through that our eye desires or wants, we can get into huge problems. We realized several years ago that a certain manufacturer was making a very green tinted glass.
Yep.
But the color that resulted and was coming through was a mixture of brown, reddish, green color that was quite depressing.
Yep, very dark.
Very dark, very dull, light. Yep. And it was the color spectrum that was so important. So if we look here at the CIE lab system of the color, it's very important to start considering the type of the color of light that's coming through. And I have to say that those that personally that deal with the bluer colors allow a much brighter, a larger palette of color to come through and be filtered through the glass. And those glazing systems have been highly successful and accepted by the user.
The color of your window is particularly important if you are doing work like if you are an artist doing painting or if you're a graphic designer. It will affect how you perceive color. So if you are doing a lot of work related to a very precise color definition, pick the right choice of your window that don't distort the color.
I would also like to say that if you're looking at grays colors, well, gray is a filtering of a huge portion of the color spectrum. You get a pretty good, so often a gray tint is acceptable.
Yep.
A bluish tint seems to be very acceptable.
Yep.
I would try to avoid or be careful with brown or greenish tints. You might find them okay. Personally, I would be cautious.
Is it fair to say in the old day where we only use single glass, the difference between a reflective treatment compared to a dark color glass is significant? But since we are now moving to an IGU with double glaze, the two different treatments will be much less significant, or the difference between the two is minimal when we put them in a double glaze system?
Actually, we get the benefits of both. And that's what we have to realize.
Yep.
And that's why we talk about designing a glazing system. We want, for instance, in a warm climate like Australia, we want to filter out the right sunlight.
Yep.
We want to let the visible spectrum enter through the tinted glass, but we want to reject all the other unwanted heating portions of the solar spectrum that are not related. Now, don't forget that visible light is also heat, but it's wanted heat. About 50% of the solar spectrum is visible light.
The energy
is
50,
is about 50. And so we're still letting heat through when we have visible light coming through. But that is the wanted heat that we see by.
Yep.
And we need that.
Very often, when a customer comes to a window supplier or glass manufacturer, all they care about is how the glass look like. We got so many options here, like different kind of translucent pattern, different color, from very light to very dark, mirror finish. How should we make a choice of this? I think we need to go back and look at the principle of different types of performance on glass. When you're picking the color of your window next time, remember, you are looking through the glass to look outside. It's the same as when you're picking your sunglasses. Don't think when you look at the color of the glass inside, it looks a bit too dark. Think about how you pick your sunny. When you look outside, you want something that can protect you from the bright and sunny condition outside. So don't mind if it is a tad darker. Ask your window supplier or your glass manufacturer to give you a small sample to walk outside to look it under the sun. That's what the color and the condition you are going to see when the window get installed, not when you're looking at it indoor under the artificial light.
Yes, Joseph, that's very true. Many incorrect selections of glass are made looking at the glass inside as it is here. Inside is 8 to 10 times less bright than what we have outdoors. So therefore, the glass will always look darker than its actual performance.
Mark, thanks a lot for all the insight, just like the good old day. And we cover a lot of topic in this interview. If you guys think of any question, feel free to ask us and we'll arrange another time to sit down with Mark again and answer your question.
Yeah, thank you. You're welcome.